the chapter 3, and this chapter is satellite remote sensing. Here we are talking about the remote sensing which is performed or used by we use satellite data. And what are the key components? One is satellite platform. So based on the orbit, there are three type of orbits: geostationary, polar orbit, and sun synchronous. The difference is geostationary orbit altitude is very high, and these satellites are used for communication as well as for weather monitoring for any area, because it will not cover the whole earth, but it will cover the specific area of the earth where you can monitor the weather conditions. While on the other hand, polar orbit, it passes over the poles and cover the entire earth. The altitude here you can see 500 to 800 meter compared to 36,000 kilometer. This is not as high. This is 500 to 800 kilometer. And many remote sensing satellites uh, revolve at this altitude. And very popular satellite programs are Landsat and Sentinel. And then comes to the sun synchronous. I mean, the path is synchronized by uh, with the sun. So all the time the satellite remain uh, in the lighting condition. Uh, this is also kind of sun synchronous here. And then this is the first component which we should know about the satellite platform. Not as much important, but uh, I mean, if you are using Landsat data, then you should know that this data is taken from the satellite which has polar orbit. And then come to the sensors here. As we have already discussed, there are two types of remote sensing: passive and active. So passive sensors are dependent on sunlight, and then active sensors are they emit their own energy and measure the reflected signals. The examples are given here: radar and lidar. Then what are the key features of satellite remote sensing? This is a very important part: key features of satellite remote sensing. Key feature, or we can say the key characteristics of remote sensing data. So first characteristics which we must know is the spatial resolution. This is very important. The data you are using, satellite data you are using, you must know that what is the resolution. So let me demonstrate you something which is okay. Okay, let's see. I will demonstrate you later. So here the spatial resolution, high resolution data is ICONOS. The spatial resolution, what does it mean? It means the data, when you will zoom in, you will see the pixel. The pixel size is length and width is 1 meter by 1 meter. Here it's 0.31 meter. Here 30 meter. So what does it mean? It means if you are using ICONOS data or WorldView data, I mean, you can visualize small features at the surface of the earth. But if this is medium resolution like Landsat, you cannot visualize small things like small plants, or you cannot visualize a car because the size of the car is less than 30 meter. But if you are using ICONOS or WorldView data, you can look at the car here, the surface of the earth, there it is. Or even if you are using WorldView data, you can look at the poles also. When we come to the course resolution, is resolution especially 250 to 1000 meter here. If you want to study the larger area, for if you want to, if you are interested to study the clouds or some kind of weather, or if you want to look at the synoptic view of at country level, then you can use this course resolution data, that is by MODIS. MODIS means by NASA, Landsat means by NASA and USGS. So spatial resolution is useful. You must know what spatial resolution is, the data you are using. Now we come to the spectral resolution. Spectral resolution is, spectral means here we are talking about the wavelength. The data you are getting from Landsat, how many bands are there? There may be around 8, 9 or 11 bands. So the spectrum, the spectral data you are getting into 8 or 9 bands. In some of the platform they are giving only 6 bands. In some of the platform they are giving even more than 20 bands. So as the bands increase, spectral resolution also increases. And then temporal resolution is important. Why? Because temporal resolution is when satellite is passing through for the same area. For instance, Landsat satellite, if today is 30th January, passing through, for instance, passing through Abuja, then the next visit will be after 16 days. What does it mean? Around 15 or 16 February. So you do not know in between today and 15 or 16 February what is there, Abuja, if you are using Landsat data. So if repetitive time is less, temporal resolution will be higher. The fourth characteristics you must know is the radiometric resolution. Radiometric resolution is related to bit. What is the bit? How much bit you are using? I mean the data. Minimum and maximum value. If this is 8-bit, minimum will be 0 and maximum will be 255. But here mentioned 256. The reason is I'm starting from 0. So if you are starting from 0, you have to minimize it, 0 to 255. And then there is a 12-bit and there is a 16-bit also. So if I say Landsat data is 16-bit, okay. And then if I say Landsat 4, so this is 8-bit data. So as time passes, the radiometric resolution is also improving. 16-bit data is sufficient for the remote sensing. Now have a look at the major satellite remote sensing systems. Here, this is optical remote sensing satellites. Optical means we are talking the passive remote sensing. We are talking the sun dependent satellite system. So here example is given. This is Landsat data. This is longest running Earth observation satellite series. Right, it started from 1972. So if you are using Landsat data, you can observe the surface of the Earth. What was there in 1972? Okay, so this is an example of optical remote sensing satellite data. Then comes to the Sentinel-2, which is ESA. It's a high resolution multispectral data. We have seen it. Landsat is how much? Landsat is 30 meter, while Sentinel data is 10 meter. So this is relatively high resolution multispectral imaging data. The good thing is that Landsat as well as Sentinel data is free of cost. Go to the internet, even download the data of any area, of any, of the available time. Then we come to what view data is very high resolution, is good for urban planning and mapping. So this is about the optical remote sensing satellite. This is radar here. Radar is microwave energy. See the difference here. Optical remote sensing using the the wavelength minimum maybe 0.4 and maximum maybe 11 micrometer or 10 micrometer, right? But the radar remote sensing uses longer wavelength. So longer wavelength can penetrate the clouds and vegetation. So if there are clouds, you cannot use optical remote sensing because cloud will cover each and everything and you will give wrong information. But if I ask you to study the vegetation cover and you using the optical remote sensing data, then the cloud will give you wrong information. So this is the drawback of optical remote sensing. But you can estimate correct uh, vegetation cover using radar remote sensing data. So Sentinel-1 is most popular data. I will suggest you should explore it and you should use it. Better to use Google Earth Engine to work with Sentinel-1 data. Then, and this Sentinel-1 data is also free of cost and they do not charge anything. This is from European Union. Then we come to radar set data here and then ALOS. I think if you are interested, you can start with Sentinel-1. And then we come to the thermal remote sensing satellite data. Here, this is MODIS. There is Landsat thermal infrared. If you want to study the land surface temperature, the variation from one place to another, or if you want to see that how the LST land surface temperature is increasing or decreasing, if you want to study the what is the impact of urbanization on land surface temperature, or what is the impact of land use land cover change on land surface temperature, and if you are interested to know or to study the climate change, you have to use this data, that is Landsat thermal infrared. You can use, and you can use the MODIS data also. And then this is a hyperspectral remote sensing data. Hyperspectral means spectral means wavelength. Hyper means many. Here we see that the bands are given like maybe 7 to 11 bands, but hyperspectral sensors have more than 220 bands. So 220 bands can give you very detailed information about like maybe type of minerals, rock types, like that. Then this is the remote sensing satellite. It uses the laser pulses to create 3D mapping of the surface. Very important for the forest biomass estimation or the urban planning. Then we come to 3.5. 3.5 is moving very fast. Yeah, 3.5 is data processing in satellite remote sensing. In before some formal analysis, here you have to pre-process your data like atmospheric correction, geometric correction, radiometric calibration, and this pre-processing uh, in the present time, there are many satellite programs like Sentinel and Landsat. They already pre-processed the data and they give you surface reflectance. So when you do the remote sensing analysis, they will give you two types: top of the atmosphere or surface reflectance. So if you are getting the data of surface reflectance, meaning that they have done what atmospheric correction, and they have done the geometric corrections also, and they have done, if you are using level 1 data, they have done the radiometric calibrations also. uh, Data processing, you can do image enhancement also, you can do classification also, and then you can study the change detections also. So all these are possible with some software which are very useful, and these softwares are maybe like ArcGIS